Hello everyone. In this video, I want to go over some pitfalls that students make when drawing molecules, especially at the beginning of the semester. These are pitfalls that I typically see. It breaks my heart when I know, or I think I know, what molecule the student is trying to represent on an exam, but because they explicitly drew a hydrogen when they shouldn't have, or they drew one lone pair but not all the lone pairs, I can't mark that answer as completely correct, and there has to be some point deductions. So let me go over some of those pitfalls. That cover page showed an example of an exam problem I gave a couple of semesters ago, but before we get to that problem, let me show you what I write on every cover page of my exams. It's a note about drawing structures. You know, there's ways to shorthand your structure, right? Using condensed structures or line structures, but there are very specific rules when you use those shortcuts. The first bullet point, if you explicitly draw a hydrogen, the letter H, coming from a carbon, then you have to draw all the hydrogen atoms bonded to that carbon. So if that carbon really has 3 hydrogens, and you only choose to draw one of the hydrogens explicitly, then you are implying, or you are stating for a fact, that it's missing 2 hydrogens. And you may not want to do that. The second bullet point, in a very similar vein, if you draw the letter C, okay, there may be reasons to draw the letter C in a line structure, but if you do have to draw all the letter H's around that particular carbon. Next, and last, if you draw one lone pair on an atom, for instance on oxygen, like in a water molecule, you have to draw all the lone pairs, or else you, again, are implying, in this case, that oxygen does not satisfy the octet rule. For some reason, maybe the electron got excited, got ejected, but once you start drawing explicitly these hydrogens, carbons, and lone pairs, you have to draw all of them to make sure that the reader knows that you know that they exist. Let me show you this example from an exam. Draw 8 molecules that fit the molecular formula C4H8O. There's actually more than 8, but in this example, I wanted to see 8 different structures from the student. The important thing here, before we look at some of the answers that I got, is that there's no charge in this molecular formula. So you will assume that no atoms have a formal charge. If I give a molecular formula that represents a molecule that has a charge, I will show that charge. For instance, maybe C2H7 square brackets plus. Now in this case, if you're trying to draw a bunch of molecules with this formula, it is telling you that those molecules have to have at least one atom, or has to have a net positive charge. In this case, again, no formal charges. So when I look at my answers, or the answers of my students, I'm asking myself, are they implying that there's a plus or minus charge? For instance, if an oxygen has a single bond, well, that oxygen should have a negative charge. That would be incorrect in this case, because again, you are assuming, because there's no plus or minus on the structure, that there are no formal charges. Okay. Enough belaboring that point. Let's take a look at the first molecule here. Okay, great. I see 4 carbons here, and I know what the student is saying, I think. They're just drawing the carbon skeleton, and they are assuming that I know that there are the correct number of hydrogens per carbon. But I cannot assume that. This molecule is telling me explicitly that the student thinks, or the student is implying, that there are no hydrogens here, right? So this is wrong, because what rule are they violating? They explicitly drew the letter C, but they did not explicitly draw the letter H around that carbon. Do you see the subtlety here? I cannot assume that you know that there are 3 hydrogens on that carbon. How about for this one? This one's wrong as well, because we have 8 hydrogens, correct? If I count, I know from line structure rules that there are 3 hydrogens here. Perfectly fine. 1, 2, 3, 4, 5, 6, 7. So the student here is forgetting that because they drew the letter C here, they should have drawn the letter H here. Or else what they are implying is that that carbon only has 3 bonds. So this is wrong as well, because I believe what the student wanted to draw was this. They should have drawn this, is what I'm saying. Now, take a look at this drawing here. I want to sit on this for a little bit. This is called an aldehyde. It's not an alcohol. It's not an OH group, as some students may mistaken it for. What this Lewis structure looks like is this. That CHO group in the condensed structure up here, it looks like this in the Lewis structure. There's your CHO. It's a doubly bonded oxygen, okay? And if I complete the rest of the structure, I'm just going to make this condensed, okay? At this point, this will still be wrong. Because I explicitly drew the letter C here, I have to make sure that I complete its 4 bonds in octet. Okay, so that these two represent the same thing. This one was counted as correct when I graded structures that look like this. They could have drawn it like this, fully drawn out. I had no specification whether I wanted line structures or condensed or Lewis. And in many cases, like in this case, it's a combination, right? It's a combination of line structure and condensed. Perfectly fine. Perfectly fine. Now, other ways that you could represent the aldehyde, you could literally draw the double bond oxygen like this. Okay, so instead of having condensed, you could draw the line structure. I drew the letter H here, or I like to draw the letter H here because for me, the aldehyde looks a little bit naked when I draw it like this. But both drawings are perfectly fine as well. Okay? Whether you draw the H or not, it's a perfectly fine way to draw the aldehyde group. Does that make sense? Okay. All of these are identical. Same thing with this one down here. Next one. This is good. Okay, so again, this is the combination of line structure and condensed. I drew the letter C here, or they drew the letter C here. They need to draw the letter H's here. There are 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. Over here is not correct because this carbon right here, they drew one of the H's, but not both of them. They should have drawn this. If they really wanted to explicitly show the number of hydrogens on this carbon, they need to explicitly show both hydrogens. That's this first bullet point here. If you explicitly draw a hydrogen from a carbon, you have to draw all the hydrogens. Okay, so this is incorrect. They forgot the letter H here. Same thing up there. What about this one? Well, this one, you can't confuse it for an aldehyde because look at the order, COH. I think what they wanted to draw was this, CH2OH. Let's count the number of hydrogens in this drawing here. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, this one fits the formula. C4H8O. So this is wrong because they explicitly draw the carbon, but they did not draw the hydrogens attached to that carbon. And there has to be hydrogens attached to that carbon to satisfy the molecular formula. Either draw it like this or draw it like that, condensed. Okay? And therefore this one was considered wrong. Now here we do have an OH group. Okay, same thing here actually. And now, see, I didn't draw the letter C, so it's not imperative that I draw the letter H here. Okay, so this was perfectly fine. Let's count hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. This one here fits the formula as well. Okay, and then this one is definitely wrong because again, you drew the letter C, or they drew the letter C. You gotta explicitly draw the letter H's as well. You just can't leave it as a carbon skeleton. Now, when you're working on a scratch sheet of paper and you're trying to figure out all the different connections, sure, you could, on a scratch sheet of paper, start drawing your different connections between your 4 carbons. So maybe you have that skeleton there, okay, or maybe you have the skeleton here, carbon skeleton, right? And then you got to remember you have an oxygen. And so maybe you have the oxygen at the end here, like this, or maybe you have the oxygen somewhere in the middle, like that. But ultimately, again, this is scratch work. Okay, you have to draw real molecules when you submit your answers. So these are not real molecules, right? You have to add the letter H if you're going to draw the letter C, or you're going to convert all of these to line structures. Like for this one here, you could start out like this, okay? But that one has too many hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So go ahead and maybe put unsaturation, put a double bond to remove some of the hydrogens. Let's do that. This is C, 4, H, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, I went through this kind of fast. You need to practice, or my students need to practice in their homework notebook, and let me check it or show it to your instructor to just double check, because it is kind of very easy to fall into these pitfalls, especially when you're working under time constraints. Okay? A lot of practice, a lot of training your muscle memory, right? Your muscle memory is going to kick in. When you draw the letter C, you're going to automatically remember, oh, I got to draw all the letter H's. Now, I didn't ask for lone pairs here, but again, if you draw one lone pair, okay, if you leave it like this, you are explicitly telling me that it does not satisfy the octet rule for some reason, which it's possible, but it's not a correct structure for this problem here. You have to draw both lone pairs, okay, because we are making sure that all the oxygens satisfy the octet rule and all the carbons satisfy the octet rule when they are neutral, when there is no formal charge.